Hello friends, in this video we will cover the time and space complexity of diversion that we covered in previous video. Okay, that I already covered. So for that purpose we take code of that lecture and try to analyze what is the space and time complexity. Okay, this is actually the code of this. So if you think about time complexity, okay, and also the space complexity, simple this is simple to analyze what is the space time in this. This is one for loop they call for v number of times, and this is function that will call for each node. Here no restriction, that means this for loop will run for v number of times. That means time complexity here is v for this for loop. And if called for one, let's call for one, then one will call 2, so that 1 2 edge will be involved. If 2 will call for 1, then again 1 2 call will be involved. Okay, if 1 call for 2 and 2 call for 1, that means 1 2 edge will be involved 2 times. That means each edge will be involved 2 times. And also for this for loop, for all nodes for each nodes this DFS call will be called. Okay, and if one will be called, then one called for 2 if 2 is unvisited. If that means if 1, then 1 called for all neighbors. That means if 2 is called from 1, then 5 cannot call 2, 6 cannot call 2, 4 cannot call 2. Okay, that means all nodes will be called in DFS function only one times, and each edge will consider 2 times, from 1 to 2 and 2 to 1. So that means total time complexity is big O of, for total node v, and for every edge 2 times, that means 2e. This is actually the time complexity of this code. Okay, it's same as adjacency list time complexity, but a space complexity will be some different. Okay, because a space complexity is here adjacency list is already given. This is graph, so we cannot consider adjacency list. Here is one list that will store the answer, that will store the all vertex. So this is big of v. Okay, that will store. And if we call for each node, that means DFS recursive function will be called for each node. That means DFS recursive call will be called for each node. That means again v times this auxiliary space. Okay, sorry, this is the stack space that is used by recursive call. So big of v plus v is the space complexity of this code. For this code, space complexity. So time is big of v plus 2e, and a space is big of v plus 2v. So the time complexity is big of v plus 2v, and a space complexity big of v plus v. That means big of v for this code DFS. Okay, thank you. And about DFS will be discussed in the next video.